All right, what's the first thing we do? First thing we do. I gave you 3 steps. They're in your notes. What's the first thing it says do? What? Put everything to sine and cosine. What trig function is not in terms of sine and cosine up there? Everybody please look up at the board and tell me. Tangent. Tangent's the only thing I got to change. Because everything else is already in sine and cosine. So I get cosine x plus sine x all over 1 plus, and the quotient rule says tangent's what? Sine over cosine. Now, we did one the other day that was a complex fraction. This is a complex fraction. So here's my question to you. Yeah.
How come you didn't do the return of the
Okay, is that what's the one that's secant squared equal? That identity says secant squared equals what? Nope. 1 plus tangent squared. That's the identity. That's the Pythagorean identity right there. This does not say 1 plus tangent squared. This says 1 plus tangent. So 1 plus tangent does not equal secant squared. So let me show you this. If I have, all right, let's say I got 3 equals, let me show this to you. 3 equals 1 plus 2. How about that? Right? Now, does 3 squared equal 1 squared plus 2 squared? No. 9 does not equal 1 plus 4, right? When you do not have a square, you cannot use Pythagorean identities. You must have square in there to use Pythagorean identity. Everybody understand that? Because squaring does not always equal each other when you square stuff. So the only time it does is when you got 0 squared or 1 squared. That's it. So we cannot use that. All right. Now this is a complex fraction. Anybody know why it's called a complex fraction? We did. There's more than one fraction bar. That's why. So what you want to think of is that every single part up here, every single part has can be made into a fraction by putting ones on there. You remember how I showed you to find the LCD? What do we do with 1, 1, and cosine? What do we do to find the least common denominator or the least common multiple of all those denominators? The least common multiple of the denominator is the same thing. What do we do? We took whatever was in common with the bottoms. Anything in common with all those denominators? A 1, so we can write a 1 down. And then everything that wasn't in common, we multiplied along with that. So cosine x is my LCD. So what I told you to do was I told you to multiply the bottom and the top by that. Now this is going to maybe seem weird, but I am not doing distributive property on the top. I'm going to tell you why. My goal is to reduce. So if we did distribute on the top, it would give us something that we would have to factor out later to get it to reduce. So I'm going to leave this factored in the top, and I have cosine x plus sine x. And by the way, you can put the cosine afterwards or in front, does not matter, because 3 times 2 equals 2 times 3. That's called commutative property multiplication. So you can put your cosine at the end or at the front, does not matter, and that's what's on the top. I am going to distribute it on the bottom because I want to get rid of the fraction. That's why I'm going ahead and multiplying that. I want to get rid of that fraction. So I got to take cosine times 1. I hope we all know that one. Then I'm going to take cosine times sine over x. Again, I took cosine over here times this. And then I'm going to take it times this one. Yes, ma'am.
I'm confused why you would choose cosine x over 1.
Okay, I found the LCD We talked about it in the video. You can go back and watch the video. These are the denominators of the original part. That's a complex fraction because I have a fraction bar and another fraction bar. More than one fraction bar makes a complex fraction. And to get rid of a complex fraction, you multiply everything by the least common denominator. So if you look here, to get the least common denominator, I took the ones that were in common, and then the cosine that wasn't in common, and when I multiply those together, that gives me this cosine. That tells me that this thing right here is my least common denominator. So I'm going to multiply the top by that cosine and the bottom by that cosine. I made them fractions right here because these were fractions, and you multiply fractions straight across. Does that answer your question?
Yeah.
Okay, and so, again, I am not distributing, I'm leaving these separate on the top. And I just drop the ones off because anything divided by one is itself. Okay? And then down here, I take cosine times 1, and that's cosine on top, and 1 times 1 on the bottom. So cosine divided by 1 is cosine. Then I'm going to take this cosine over 1 times this sine over cosine. What do I get to reduce? Anybody? I get to reduce this cosine with this cosine. They reduce to 1s. So what am I left with here? What am I left with on the bottom, over there on the right of the plus sign? What's the only thing left besides 1s? Sine. So sine times 1 is sine, and 1 times 1 is 1, and I get that. Now, can anybody tell me why I did not distribute cosine on the top? Look at the problem. Look at the parentheses on top. Look at your denominator. What do you notice about them? They're the same thing. What do they reduce? What do they do? Anybody? They reduce. This goes to 1, and this goes to 1. So what? On the top, I'm left with 1 times cosine, which is cosine. On the bottom, I got 1, so there's my answer. Boy, it'd be nice if you all played the game. You're all welcome to join in on our party. We're having a math party every day. You can all just throw out there. What's the worst thing that could happen when you give me an answer? Worst case scenario. What's the worst case? You're wrong. You are wrong. I'm wrong every day. I'm still breathing. It's okay to be wrong. Learn from your mistakes. That's the goal of education. That's one of the goals of life. You all are going to make millions of mistakes. It's okay. How many people are perfect in our world? How many perfect people? None. Mother Teresa, one of the finest people ever lived on earth that served people. She was not perfect. Whoever you think's perfect out there, they're not. Nobody is. Nobody's perfect. How many people in this world feel anxious about things? How many people get anxiety a little bit sometimes? How many? Everybody. It's normal. It's normal to get a little anxious about things. It's not abnormal. Life isn't easy. It's hard. So it's normal to be a little anxious. Okay? Don't be upset by being anxious. It's okay. You ought to get used to it a little bit. You ought to start embellishing it, because you know what anxiety does to you? It prepares your body to be ready for something. It's a good thing. It makes your body more aware of what's going on around you. You ever been when you were a little kid and you were home and it's dark and you were scared and you got all nervous and scared a little bit? And you could hear every little thing in the house, couldn't you? Because you were scared. Your body prepares you to be ready for things. It's normal. All right. Anyway, I'm going to shut off the video.